Okay, so in this video I'm gonna teach you how to convert a recurring decimal into a fraction. So the process is actually a little bit more complicated than what we're used to, but hopefully after this video you will be comfortable converting these kind of numbers into fractions. So the first thing we need to take into account here is that this is a number that has this 6 repeating over and over again. So the first thing we're gonna do is to set up a variable x, and we're gonna make it equal to this number. So we're gonna say x is gonna be equal to this recurring decimal. Now so far that doesn't look like a very useful thing, but the next thing we're gonna do is we're gonna say, okay, so by what number can we multiply this so that the decimal point moves 1 unit or as many units as it needs to, so that it actually completes one whole pattern of these repeating numbers. In other words, if we had something like this, right, this would mean that we have a number that is the pattern that is repeating is the 15, so we have 1 5 1 5 and so on. Then in this case, in order to basically move the decimal point so that it completes an entire pattern, we would need to move the decimal point twice. So basically the number we would be looking for would be something like this. And if we had like 3 decimal places repeating, we would need to move the decimal point 3 places and do the same thing. In this case, we only need to move it once because the repeating units are already in the beginning, so we're going to have the following situation. We're going to multiply both sides of this equation by 10. So this is going to be 6.66666. And I should write the 3 dots here just to show that this is actually a recurring decimal. And now look at what we're going to do. We're going to subtract x from 10x, and the reason for that is that all of these decimal places, because they're all the same, they're going to cancel out to 0, and we're going to be left off with a 6. So we can write 10x minus x is going to be equal to just 6. And then on this side we have 9x equals 6, and we can rearrange that equation by dividing both sides by 9, and then we're going to get 6 over 9. And since both numbers are multiples of 3, we can divide each one by 3. So this is going to be simplified to 2 over 3. And you can check on your calculator that this answer is actually going to give you that recurring decimal. So I guess the main point of this is to always try to look for how many numbers are repeating in the pattern, and then just see what number you need to multiply this by so that you can actually do this kind of calculation. So it's a very simple equation to set up, but the tricky part is when people are trying to decide, oh, okay, so how many decimal places do I need to move the decimal point in order to get this right? So I guess another example I could give you would be something like this. So 2.3, let's do 4. So in this particular case, what we have here is a number that has a 4 repeating all the way to infinity. But we have this decimal place here that is not actually repeating, but it is in between our whole number and our recurring decimal. So in this case, as you might guess, we actually need to move this decimal point 2 times to the right. So let's write x equals to 2.3444 and so on. Then we're going to multiply this by 100. So we're gonna move this twice, 234.444. And you might be thinking, well, hang on a minute. If you actually subtract these two from each other, you're not gonna get a whole number, are you? So clearly this is not a good choice. Even though we assumed at first that we could actually just move it twice because that's when the units started repeating. That's actually not how you would do it, because if you subtract this from that, you're not actually going to get a whole number, you're going to get another decimal. So in this case, we need to try something different. So let's say we multiply this by 10. So this one is going to be a bit trickier, because let's say if we multiply this by 10, that's going to be 23.444. And hang on a minute, that's actually not going to become a recurring decimal again, so that's gonna be a little bit of a problem. Okay, so how can we actually do that? Well, in this case, it doesn't really matter whether we choose to multiply by 10 or 100, because in the end, we're not going to get a whole number. So this is one of those cases in which you have to be a little bit creative and say, okay, so let's just do it by 10. And now if we subtract 10x minus x, well, we know that this number, so from the second digit onwards, all of those numbers are going to cancel out. But then essentially, this one is going to be 4 minus 3, that's going to be 0.1. But let's do the 23 minus 2 first. So that's going to be 21.1. So basically, this is the number that will result from subtracting those two. Now, if we want to express this as a fraction, we need to try and find out. Okay, so we need to obviously multiply this by 10 once again, so that we can actually express it as a fraction. So in this case, we're still gonna write 9x on this side, but this one we can express as a fraction because it's a non-recurring decimal. So we know how to do that already. Okay, and now what we're going to do with that is we're just gonna multiply the 10 by 9, so that's gonna become 211 over 90. So we can check that in our calculators, and that should indeed give us 234 with the 4 repeating over and over again. So in some cases you have to be a little bit creative. We could have also multiplied by 100, but it would have been the same case, and then we would have gotten an even larger number that we would have had to simplify once we get to this step. So I guess going about the simplest way, try to multiply by the smallest number you can, and then just work around your way by converting that non-recurrent decimal into an actual fraction, and then complete the equation. And we're gonna do some more examples of this in the next video.